Dear students, I am going to discuss routing in Omega network, which comes under third module of the course CS 405 Computer System Architecture. Omega network is a popular multi-stage interconnection network. In a multi-stage interconnection network, the processing elements are connected using multiple stages of switches. Omega network is constructed using 2 by 2 switches. That means the switches have 2 inputs and 2 outputs. Using 2 by 2 switches, the possible connections are straight, crossover, upper broadcast, and lower broadcast. In a straight connection, when we give 0 as input, we'll be getting 0 itself as output. And when we give 1 as an input, the output is also 1. In crossover connection, when we give 0 as input, the output is 1. And when we give 1 as input, the output is 0. In upper broadcast connection, when we give 0 as input, we will be getting 0 and 1 as output. And in lower broadcast, when we give 1 as input, the output is 0 and 1. In Omega network, there are multiple stages of switches. The output of one stage connect to the input of next stage using perfect shuffle connection system. Perfect shuffle is obtained by shifting one bit to the left and wrapping around the most significant to the least significant position. So we'll see this using an input set and output set. This is input set and this is output set. The input is connected to the output using perfect shuffle. So in perfect shuffle algorithm, the connection is determined using a logical rotate left. So let us take the first input 0 0 0. So if we perform logical left shift, when we shift the 0 0 0, the output is 0 0 0 itself. So the connection can be done from 0 0 0 to 0 0 0. And next take the second input 0 0 1. So when this 0 0 1 is left shifted, the 1 in least significant bit will be going to the middle bit and the 0 in middle will be going to most significant bit and the 0 here will be going to least significant bit. So the 0 0 1 will become 0 1 0. Okay. So the connection from 0 0 1 is to 0 1 0. Okay, so 0 0 1 will be connected to 0 1 0. And next take this next input is 0 1 0. So 0 1 0 will be connected to 1 0 0 because this 0 will be moving to middle position and 1 will be moving to most significant bit position and this 0 will be moving to least significant position. So 0 1 0 will become 1 0 0. So the connection from 0 1 0 is to 1 0 0. Same way 0 1 1 will be connected to 1 1 0 and 1 0 0 will be connected to 0 0 1 and 1 0 1 will be connected to 0 1 1 and 1 0 0 1 1 0 will be connected to 1 0 1 and 1 1 1 will be connected to 1 1 1. Okay, so input set. So when we left shifting the input will be connecting to the output to that particular bit pattern. So this is how the perfect shuffle algorithm works. Next we'll see how we can construct an 8 by 8 omega network. An n-input omega network has log n to the base 2 stages of 2 by 2 switches. So if there is 8 inputs, then we have log 8 to the base 2, that is 3 switches are needed. Each stage requires n by 2 switch modules. So if the input is 8, then we have 8 by 2, that is 4 switches are needed. So each switch module is individually controlled. Here is the 8 by 8 omega network. Here the inputs are 8. So we need 3 stages, that is stage 0, stage 1 and stage 2. And each stage is having 4 switches. Switch number 1, switch number 2 and switch number 3, then switch number 4. Okay, so there are 4 switches and 3 stages of switches. Okay, so in the stage connections, stage 0 and stage 1 will be connected using perfect shuffle algorithm. So we have seen perfect shuffle algorithm. So in the stage connections are done using perfect shuffle algorithm. And the routing used in omega network is self routing. It is also known as destination tag routing. So in this destination tag routing, the source node generates a tag which is binary equivalent of the destination. At each stage, the corresponding tag bit of destination is checked. If the bit is 0, the input is connected to the upper output. If bit is 1, the input is connected to the lower output. If both inputs have either 0 or 1, it is a switch conflict. One of them is connected, the other is rejected. So we will see an example of self-routing. So here there is a cell destined for output port 4. Okay, so the source is port 1 and the destination is port 4. Okay. So at source, it generates a bit pattern, a 3-bit pattern will be generated and it is equivalent to the destination. Okay, so there is a 3-bit pattern generated at source and it is equivalent to destination. So at source, a bit pattern will be generated, that is 100. Okay, so 100 is the binary equivalent of destination 4. And then when it reaches at stage 0, so this is stage 0 switch and this is stage 1 switch and this is stage 2 switch. Okay, so when it reaches stage 0 switch, it checks the most significant bit of the destination tag. So it will be checking the most significant bit of the tag. So here the most significant bit is 1. So the input is connected to the lower part of the other end. Okay, so inside switch, how the connection has been done? It has been done using this bit pattern and it will be checking the most significant bit at stage 0 and at stage 0 it is 1. Okay, so the input is connected to the lower part of the output at stage 0. And from here, the only connection is to here. And then when it reaches stage 1, it checks the middle bit of the bit pattern. So the middle bit here is 0. So it connects to the upper part inside the switch. So stage 1, the input is connected to the upper part of the output. And then it comes here because there is only one connection from here. So it comes here, and at this stage it checks the least significant bit. So here the least significant bit is 0. So inside the stage 2 switch, the input is connected to the upper part of the other end. Thus, it reaches the destination. So the destination 4 has been reached. Okay. So from port 1, the cell is destined for 4 and it reaches here using this destination tag routing. So this is how the destination tag routing or self-routing is done in Omega network. So today we have discussed routing in Omega network. Hope you all understood the concept. Thank you.